Welcome back, friends. This is the last final chapter in our Frida journey over here. This is the missing piece in our puzzle, hooking NDK functions, and this is also freaking awesome. We will later see how we can solve complex challenges or tasks in just a few minutes. But before we can do this, we have to unfortunately do a little bit of theory. Therefore, let's have a look what we have done so far and what's the difference from now on. Here we are having our smartphone, and the application we have seen so far are mostly, or I guess all, written in Java. No, the game, the Space Ping application, I guess these has some native code, but all the others, I guess these were written in Java. So we've got our Java world, and in our Java world we can now navigate easily around this. We can hook method, classes, instances, whatever we like. And all of them is done via the JVM, the Java Virtual Machine. So we have seen those two approaches, java.use, getting those class references and performing some really nice actions on this one, and java.choose, scanning the memory for instances and working directly with them. So manipulating games like the Space Ping application to perform or create an own trainer. This was a lot of fun. Unfortunately, this is now over. Not the fun part, but the java.use and java.choose part. So if you're dealing with C, C++ code, we have to memorize another scheme. So we can ignore now java.use and java.choose and welcome interceptor.attach. This is how we can hook native function with Frida. And yes, unfortunately, you heard right. With Frida, manipulating a function is easy, but accessing instance fields or classes pretty impossible without having the address. But that's most of the time all we need. I mean, if we can manipulate a function, those parameters or return values, we can perform, I guess, 90% of our task right now. And regarding to our C, C++ code, this is enough. You will see this later on how much ability we still have only by hooking functions. Alrighty? Okay. The structure to interceptor attach is pretty identical to java.choose, but also different, of course. So the first parameter over here, that's our native function pointer. We can get this pretty easily in Frida. Therefore, it's also not that hard to hook this. And we will later see how we can do this. And for now, we just keep this on a high level. Okay, so here we are inserting the pointer of our function we want to hook. The second parameter, these are now our callbacks. This time we are having onEnter and onLeave. OnEnter means right now if we are entering a function. And this means we are only having access to the parameters in the onEnter callback. The onLeave callback is being called just before we leave this function, so we can apply some patches regarding to the return value just before we are leaving this out. Alright? Okay. OnEnter, easy access to parameters. OnLeave, easy access to the return value. Okay, now let's have a look into an example. So how is the C, C++ code being included in our Java code? And therefore I have prepared the following application. This one over here. On the first look, it looks absolutely just pure Java code. And maybe, yes, I guess it is also pure Java code. But in there we are now having the bridge from the Java world into the C++ world. Let's have a look. So the first thing over here, we've got this main activity. Alright, then we've got two variables. And here we're having now something new. We've got a static declaration. And this one here, that's a function, system load library, and here we're having now the library that's being loaded. This is the file, the shared object file in our libs directory of this application. And this means this native-lib.so is now being loaded into the context of this main activity over here. And this means the C, C++ code is now being available over here. But we have to build some kind of bridge first. So we have to build a bridge from the Java world into the C++ world. And this one is being declared in line 25 in our Java code over here. So if we go down to this one, here we can see we are having a normal function at the first view. So this one is the return type. It's returning back a string. And we've got this function encrypt string. This one takes our pass and an integer value named as round. Alrighty. Beside this, we are now having this native in front of this. And this is the pure identifier that this one over here is a native function. So this function, encrypt string, is now being defined in our library over here, in this native lib. And therefore, identifying native functions is super easy in Android. All we need to do is we need to search for this one over here, this declaration, native in front of our function. Then we know if you're looking for this function code right now, we have to take a look into the library. Alrighty? Okay. Last but not least, we can call this function right now over here. So here we are calling this, and by looking at this one, we cannot tell if this one is now in Java or an NDK function. But we also do not bother about this right now. The main important parts are these one. Let's recap this real quick. So our main activity looks on the first view like Java code, this one over here. But on the second view, we have also identified this public native string encrypt function. And this one is C++ code. To make this function accessible in our code, we first need to load this library where this function is being defined. This one over here, the native lib so. Then we need to make a declaration from the Java world into the C++ world. And this is being done over here. So here we are making our prototype of this function, this declaration. And by appending this native, we now know, okay, this function is being defined in this native library, but this is the prototype of this. So we need to provide 2 parameters, and we are expecting a string to be returned. After performing these 2 steps, we can now call this function in our code. And this is being done over here in line 18. So we can simply access this function with the function name and the parameters we need to provide over here. So this is finally all. These are the steps we need to do to call this NDK function right now. Okay, for now I have only one question left. How is this function, or how does this function looks like in the C++ world, this encrypt string function? And therefore I have also attached the source code of this one over here. So let's dive into this. All right. Okay, so here we have it, this time with a different name. So here I have named it decrypt string, but the functionality is absolutely identical. I have just played around with those names over here. Okay, on the top we've got the Java code, and on the bottom we've got now the C++ code. And so we've got our includes, and then we've got this really strange looking function name over here, this one. This is now the complete class name. So we can see we are having this Java in front of this, but then we've got the com app hacking NDK Frida, that's the package name. And then we've got the main activity, which is the class name. And after this one, there's now the method name finally of this function over here. So we know right now, okay, we are using the decrypt string method in the main activity class, which is seen over here, this one. And therefore we could have multiple functions with the same name, and we wouldn't interfere with them in our application, because we are already providing, or always providing, this huge package name, including the class name in front of this. All right? Okay. I mean, that's not something interesting. This is just something we need to know. The next one, this one is really interesting, because here we can see now the parameters of this function. And we wouldn't even recognize this if you're not taking a close look onto this. So we can see over here the decrypt string, this one has 2 parameters, the password and also the round. And here we can now see, we are having 4 parameters. We are having a chain I environment, we've got a J object, then we've got a J string, which is named password. I mean, they do not need to match over here those 2 parameters, because this is C++ code, this is the Java word, but the types over here, these need to match. Okay, last but not least, we've got this round or rotation parameter. As already mentioned, the name doesn't matter, just the type. Now's the question, what are those 2 in front of them? These chain I environment and J object. We also need to keep this in mind, because this is very important. For example, if we want to access this parameter over here, we would have assumed that this one is args0, because we are only having 1 parameter in here. But we are also having those 2 in front, this one and this one, which means this one becomes not args0, this one over here is args2, and this one over here is args3. All right. This is something we definitely need to keep in mind. And now let's talk about what are those 2 right now. The first one, the chain E environment, this is a very important one. This is a pointer regarding to all those functions, all those chain E functions. And this can come super handy. Also during the coding, because we can now access these functions to perform some typecasting. We will have a look into this one in a moment. The second parameter, JObject over here, this is a pointer regarding to the current object. This can be completely ignored for us right now. This is really not relevant. All right. So we are having a pointer regarding to all the NDK functions. We've got a pointer to our current object, and then we've got our 2 parameters. Alrighty. Last but not least, we've got a return value, this one over here. And here we can see we are already making use of this function pointer, this environment pointer over here. Because a string in the C++ world is not the same like having a string in the Java world. I mean, we are talking here about two completely different programming languages, and therefore it's absolutely understandable that these are not compatible to each other just right now. And therefore we're having a lot of helper functions that makes this transition from C++ into Java and also backwards way easier. And one of them is within the environment function pointer over here. This is being called new string UTF. So here we are providing now our C++ string, this one encrypted PV. Then we are calling this method cstring, which creates a C string out of this one. And then we have this new string UTF, which makes out of these a compatible string in our Java world. All right? Maybe not, because this is really much right now. So let's try to recap this a little bit. Okay, so we're having our function definition over here, this public native string decrypt string. This one is a native function, therefore the declaration of this function is within our C++ code in the shared object file. We can see this over here. Unfortunately, we are not having the source code if we are reverse engineering our applications right now. Unfortunately, we are not having the source code over here. This is not being available in our applications that we are reverse engineering. We can also not construct this in a way like we have seen this in our Java world. So this one over here, this one would be assembler and therefore way harder to read. But that's also not required. We can see over here, for example, we are providing a string and password and some integer value regarding to rounds, and we can see it's being returned something back. If we are hooking this one, then we can observe and manipulate it. And we can see what password goes into, what decrypted text goes out, things like this. Alrighty? Okay. And then we have seen this decrypt string has a huge prefix. This is Java underscore, then the whole class name, and then we have this function name, this one over here. This is also important because if we are searching our functions later on, we will always have these huge prefixes in front of them. So if you're looking for decrypt string, we have to look for the function name at the end of this string we are returning back later on. Okay? All right. Last but not least, we can see it's not that easy to simply just return back a string. So we cannot use our string in the C++ world and simply return it back. We have to typecast it. And this is being done over here with the environment function pointer. This is typecasting this to a string that can be understood in our Java world. This is why we are having this definition over here in our Java world, that we know what we are expecting and what we are presenting to this function, the arguments and also the return value. All right. So this is all right now for this video over here. I'm sorry that it has been only in theory part, but in the next one we will already hook this method and modify it. Because if you want to deal with native functions, there's an easy way and also a very hard way. The easy way is something we already know right now. You might not recognize it, but you will see later on it's very easy to hook things like this. The hard way will be also included in this course because I have seen a lot of questions out there on how to hook these parameters and return values, and I have rarely seen correct answers for this one. Alright, after figuring this out, the easy and hard way, we will have a look into the amazing way. This is the last way, and this one it's freaking awesome. This is how we can hook functions, for example, like string compare, string copy, mem copy, and more. I do not know more functions right now, but I guess there are more. And this one is really amazing. I mean, this is really fantastic. We can perform complex tasks in just a few minutes. And for example, we are dealing with a challenge, which is comparing a password in this application within a C++ function. For example, over here. And we will find a way on how to hook this part directly within a function. So not just the parameters and return values. We will see how we can hook this part in a function and get out the correct password out of this. So this is the amazing way, and this is the last part in our journey over here. Afterwards, you become an absolutely Frida expert. So you can hook and manipulate things like you couldn't imagine right now. Alrighty? Okay. So therefore, I'm really looking forward to see you in the next video.